Time to start.
All right. Timer don't lie. Time to start. All right. Let's do Advent of Code. Day 7. Now I'm 2 days behind. So I'm not keeping up. I got 2 kids. Cannot stream on the weekends. And I wanted to just work them all in public instead of working some on the weekends in private. So let's go. The historians, blah, 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 rope bridge. Interesting. What's this one? In 2022, day 9. I do remember this one, actually. All right. Let me know in chat, by the way, how the sound is. Again, I never have any idea. So if the music's too loud or I'm too loud. Okay. You're trying to do something. How long did it take to be fixed? Look, somebody stole all the operators from their calibration equations. They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of their operators into their calibration equations. Okay, so yeah, I don't know what this means. Each line represents a single equation. The test value appears before the colon test value, okay? It is your job to determine whether the remaining numbers can be combined with operators to produce the test value. Okay? So like this times this, right? Operators are always evaluated left to right, not according to precedence rules. Oh, geez Louise. Okay. Furthermore, thanks Vapid Babble. What's up, K10Ma? Furthermore, numbers in the equations cannot be rearranged. Okay. Glancing into the jungle, you can see the elephants holding 2 different types of operators, add and multiply. All right. Only 3 of the above equations can be made true by inserting operators. This one. Okay, so you can do that times that, like I said. That plus that times that. And that times that plus that. Interesting. Interesting coincidence, or not. And then that plus that times that plus that. All right. Oh, no. You know that there's some math nerd thing here. The math nerds got this one on lockdown. I only know the brute force. Have either of you solved this yet? Vapid or K10ma? Like, I only know brute force. They just need the total calibration result. This is the sum of the ones that could possibly be true. Okay. I'm not sharing my browser. Get out. It's Monday. I'll wake up eventually. All right, so I read through this whole thing. So the deal is you take these 2 numbers and you can multiply them and get that, right? If you multiply these 2 and add 27, you get that. If you multiply these 2 and add 81, ironically, you get this, right? So you're looking for things that you can add or multiply to get the number on the left, which I'm tracking. I feel like there's some math nerd way to do this in like closed form equation, but I have no idea. We're just gonna brute force it. See where we get. See how long it takes. Source 2024. New namespace. Day 7. Zoom in. Don't let me not zoom in. Boom, 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 boom. 10. Okay. Have to fix that in a second. I updated my Mac and I updated my IntelliJ. So we're gonna find out what all bugs there are in the latest version of everything. I'll zoom in that a little bit. Okay. First things first. Split lines, as always, into this map, the line. I think I'm going to do the lazy thing. I think I'm going to replace colon with nothing. We're going to replace colon with nothing, and then we just have a list of numbers. Nah, this doesn't quite work like I want it to work. Stir, replace L with nothing. And we're going to put that in a vector. And we're going to slurp it. Or read it. Just read string it. Right? Eden read string. And then we'll go ahead and parse that out a little more, give some things some names, because that's how we doozy. The first number is called a test value. Test value. And nums. Test value in nums. Not TF, TV. All right, and so we'll return TV test value nums. Let's vec it. All right, this should be good. Parse T. I've been meaning to call out, by the way. I haven't done this. I did in years past, but it's interesting to see, like, I hope everyone finds it interesting to see how you develop equations. You develop programs in Clojure, right? There's a lot of just interacting with this from your code and building the program at the same time as you're running little pieces of the program. So I'm hoping that this is a good resource for people to see how this looks in action, because it's hard to explain to somebody the value that you get out of it, you know, with words. You kind of have to experience it. So hopefully this program provides a little bit of that. I'll try to call it out a little more as I'm doing it. All right. So we have another, just a valid thing. We need to evaluate whether or not they don't have a word for this. Yeah, so we'll just say valid. We have the test value. Nums. Okay, and so the question is there any way let's see the test input real quick. I mean, the actual input. Okay, none of them are crazy long, which is good. You kind of need like every permutation, like add, right? Multiply, add, multiply, add, multiply, right? All the you have 1, 2, 3 slots, and you want all the permutations of multiply, and add for those 3 slots. Luckily, there is a permutations function in math.combinatorics. Here, I'll show you. I just have it pulled in from years past. Org Clojure math.combinatorics is where I'm pulling this from. Double check how this works real quick. And again, like you just, what do? You just pull it into a rich comment and see, hey, how does this thing work? You know, A, B, C. Load it and then do it. Okay, so this is A, B, C, A, C, B. Okay, this isn't quite what we need, right? This will tell you the permutations of a given list. Is it combinations? I think this is more it. So if we had 3, wait, the items come first. We have plus and we have, look, let's just do a symbol for now so we can actually read it. So the output of plus, right, if I print it here, is that, which is like not incredibly helpful. So if I put it as a symbol, if I backtick it, sorry, not backtick it, tick it and put a plus, then I can actually read it. So if you do plus and multiply for 3 slots. No? Fudge. How does this work? Tacking T different elements. Yeah, that's supposed to be a number. From items. Huh. This is not what I expected. Do I need to, does it need to be a set or something? No. All the unique ways of taking T different elements from items. Here, let's just go to math. Combinator. Oh my goodness. The whole world's gonna know I cannot spell to save my life. Okay. Combinations. Yeah, combinations. Am I crazy? Wait, does it have to be numbers? Does it not do 1, 2, 3? Huh? Combinations. Chat, please. Oh, well, this can't be 4. That can't be 4. Oh, is that what I did? What did I type in? Wait. Oh, I did do 4. You can't have it greater. How do you do this? I mean, I guess I could. No. Look, let's look through here. Like, I have a set of operators, and I want to see for a given a list, you know, a length n, how many combinations? Permuted combinations. Let's try this. Permuted combinations. Can I do 4 of that? No. This makes sense, right? I feel like, am I not making any sense at all? Like to say I have a set of n elements and I want to create I want all the permutations that are m long. Well, what are another way of doing this? A 4 comprehension? Is that the what? Is that what's up? Man, I guess you can do it with map too, right? How does it work? So if we do it this way, what do we need? We need, like, okay, let's just type it out. If we have 1, 2, 3, 4, and we have plus and minus, we want times, plus and times. We want 1 times 2 times 3 times 4, right? I feel like this is so obvious to me, and for some reason, like, it's not coming to my brain. Help, chat, help. Send help. Plus. Right, this is basically binary counting. Plus here. Right? And then times, like, you find all the permutations where plus it has 2 items, and then you find all the permutations where plus has 3 items is 3. This is what we want, right? I'm trying not to do like the crazy thing, because you can do this with like a bit adder, I think. One, 2, 2. I mean, not partitions. No, I feel like it's not here. This exact operation that I need is not quite here. We need, for a given thing, like a partition over a range. Yeah. I mean, I think you could do it with a range. If we do range 3, right? Let's see. And we take I to be the number of, let's pick an arbitrary one, let's say pluses. We're going to start with times, and this is be the number of pluses. Then we could say try selections. Oh! Yeah. Clojure guy. Given the name, you know you had to be there. You know what's up. Let's see, we could do plus, we do minus. Wait, times. And we say, let's do 4. Yes! Clojure guy! Yes! Alright. So this gives us the, okay, so, yeah, let's get an example. Let's get, this one with 4. Okay, so we have, we can generate these, right? All the permutations of this. Um, L is that. And so we need to get the C, the count. Yeah, we don't actually have to remember that, I don't think. We need to do selections of plus and times over the count of L dec, right? We need one less the count of L. Will be the number of slots in between, right? Whoops, slurp. And then we need to map over that, over L. Ooh. Not map, we want interleave. Well, oh yeah, let's just go ahead. Interleave L with that. That is not at all. What is it we need? Cycle L. Map over selections. Cycle L. This will be the line and the selection. Interleave that, right? Again, notice how I'm just sitting down here in this comment trying to figure out how to do this program, right? I seek from long. What? I seek from long. Where are we seeking? I seek from long. What? When you're trying to print. It's telling me that. Oh, wait. Oh, no, this is cycling L. Oh, wait. We don't want to just cycle L. We want to repeat L. There we go. Huh? Oh, that's right. It's trimming the last thing, though. That sucks. 686. Is that how interleave works? It goes until it's out of one or the other? That's irritating. Either way, I don't know if we necessarily need this, right? At this point, we can do our reduce. We're gonna go over the what? Reducing. Hang on, let's do this. Map vector S and L. Wait, why is it just that's really irritating that it does that. Like all of them just go until one of them runs out. I really wanted interleave to go until the one it pulled from ran out, right? Interleave A, B, C, 1, 2, 3. But I would want D to show up if you did this, right? Yeah, you don't have a 4, but you can get as far as D. I wonder if we just give that one more. Almost. We could just drop it. Let's try that. Onto this, we want to. Conjugal. Oh, you know what we can do? Oh, I got it. Give the rest of L. Now these two are the same length. And we're going to reduce over that with the first of L, right? So the first will be the initializer for reduce. And then we get at each step the accumulation, operation, and num, right? Now we got to stop using quotes. We're going to do op, accumulation, num. Is that one of the ones that is real? Okay, and 7290 is the answer that we should not have. I mean, we don't, but let's pick one that is correct. How about this one? Pound underscore, by the way, comments out just the next form. Extremely useful when you're trying things out. The proper answer here is 292. 292 is in the set. I think this works, chat. Yeah, and it just goes left to right, right? There's no operator precedence like it said. It'll just start at the beginning of the list. Right? Starts at the beginning, and here, we'll do some nifty destructuring here. F and L R. This will be the rest. This will be the F. Bada bing, bada boom. All right, and so we want to do here. This is basically part one. Oh wait. No, we want to develop a valid font that seems reasonable. Count nums. Repeat nums. This was kind of, I kind of like this. This is, I don't know. Maybe, is this too, I don't know. Chat, tell me. Is this too clever? This is, it reads clever, but I kind of like where we ended up. I don't hate it. It's not like day, what was it? The board day. 4 or 5? Yeah, I hate this. This looks like doo-doo. This is not pretty. Not proud. This, I don't know. I could get used to this, you know? We don't have to read the whole thing. Just equal TV. And since it's a question mark, it's probably so some will return nil. Some will return nil, and we just if you have a question mark, if it's a predicate in Clojure, it's normal for you to say true or false instead of nil pun it. I mean, it's not bad either way, but I expect most predicates to say true or false. So if you Boolean it, that'll force it. That won't nil pun it, right? Okay, so part one. Input is you're supposed to sum them. Yes. All right. Util sum in. Oh, I haven't even pulled that in yet. Map. We want to filter valid. Get the valid ones. Sum them up. Hey, let's check that valid real quick. With here. Map valid. Parse T. We have 3 valid ones. That looks correct. Okay. Ooh, Clojure guy. I was about to go down the crazy train. Just like Nutter's land. Till you showed up. Okay, so we're gonna do part 1. Parse T. Great. Wait. Oh. Map. Test value. Sum the test values, right? Is that what it says? Yes, sum the test values. 3749. Boom. All right, here we go. Moment of truth. Let me go ahead and put that in. That took a second. All right. The concatenation operator. We have another operator. All right. Combines the. Oh. All right. All the operators are still evaluated left to right. Now, apart from the 3 equations that could be made true using only. Oh. This is like the tipping point, isn't it? They gave us one more stupid operator and all of a sudden permutations doesn't work. Something like that. Let's see. We're just going to copy this whole thing. I'm not going to find a way to make that work twice. Much too lazy for that. Valid prime. Valid star. That means V2. Star. All right. This is a little more complicated, right? Because we need A and B. There's no built-in function to smush 2 numbers together like this. Unless Clojure guy, you know of one. If you know one, let me know. But the only thing I know to do is to that, right? I guess if we wanted to be slick, we could do like that. That accomplishes the same thing, but you saw me. Okay, when I had to stop and think like that, that's an indicator right there. Like, it's a little too clever by half, right? This does the same thing in principle. It's very clear about what it's doing. Don't get too smart. It's pretty easy to add, but the final solution will work slowly. Yeah. Yeah, that's what I meant, Clojure guy. This is the tipping point. You just need. That's the problem with factorial expansion, right? Like, it dramatically expands the number of things you have to check. There's definitely a trick for this. How slowly are we talking, Clojure guy? Will it work, or do I have to go back to the drawing board? I'm just copying. This is literally the same thing with a star, right? Part 2. Part 2. $11,378. Uh-huh. So it does work. Buckle up, boys and girls. Will it spit out an answer or not? I guess while that works, because it may just not work. How do we speed this up? See, it's ones like this that I'm like, I don't even know. Okay. Oh, it did work. Wow. By golly. There we go. This is easier than yesterday. This is way easier. Here's the question. Well, hang on. Let's go check out what other people did. Day 7. Got to back up a couple days. Day 7, day 8, day 7. Slow, but gets the job done. Norman probably did the same thing as we did. Did not use combo, but did combo. That is what that does. Same thing with more stuff. Yep, parse long stir. Yep. Yep, basically the same solution. Incredibly slow. I'm gonna guess. Yeah, I'm gonna guess everyone who says incredibly slow did what we did. 400 milliseconds. Okay. Why is this 400 milliseconds? First, you know it, K-Tenma. Never doubted. I've only been off by once so far this year. Waiting for the other shoe to drop here. Transduce. Oh, wait. X, Y, and Y's. We have A and B. Okay. So this speeds it up by, okay, one thing that we are doing that we don't have to do is, well, maybe no. This might just speed it up by virtue of using loop recur instead of sequences. Because I think it's checking more or less the same stuff, right? Like, here's where it stops, and we're done. If there are more X's, recur with A in the X's and B in the X's, and it's done the multiplication and addition. Right, so fundamentally it's doing the same thing. It's just not doing it with sequences, which is going to be faster. Yeah. So 400 milliseconds is pretty good. Good job, Sam. Oh. Oh. I did too much thinking on this one. Did too much thinking on this one. Oh, did he update this? It looks like maybe he updated it. He says, I didn't really need all those sets. I don't see any sets in the solution. So this might be the fast one we're looking at in the first place. This one used memoization. What's the small trick, Erdos? What's the small trick? Oh, he only evaluates if, because multiplication and division, number only get bigger, right? Number only go up. He's like, hey, you could stop if you surpass TV at some point. That's good. That's good. Wait, when that though, solve, why does he subtract in? Ooh, what is this? Interesting. What are we doing here? Cut off. I'm gonna have to get Erdos to explain this to me. looks at the first digits so this is the test value. By the way, I love to see this. Somebody doing the same thing I do here with the TV. This is the test value, and then this is where we're at so far. And he's looking at, he's getting the first the difference in the lengths of X and Y, and looking at that. When the cutoff returns something. Recur in that something and in star. So if X, I don't know, I have no idea what this could be doing. If the number, if Y is the ending of X for some reason, but we're not just multiplying by tens. Like, okay, he's doing some trick I don't get. Does he explain it ever? Has anyone checked this out? Yeah, no. Big deep think. But it gets 11 and 30 milliseconds respectively, which is bonkers. Yeah, he just did the same thing we did. All right, Alex, what do you got, bro? Selections. You know it. Calc. Uh-huh. Uh-huh. Yep, same exact thing. This is like literally the same thing. We got the same brain, man. Love to see it. Andrew. Reverse the order of operands. What does that mean? Reverse, let me look at your solution. Clojure guy, are you Alex? Is that right? Reverse. I don't see you doing that. Did you reverse something here? Did I miss that? Oh, second solution to the thread. All right. There we go. Oh, okay. So you did Erdos' thing. All right. All right. Man, you got me covered today. Let's go, Alex. Okay. Parse. Parse. So it's just a normal parse. Can be true. And whether or not we cat. Okay. If oh, okay. So we start at the end. We get the first thing. Then we reverse the whole list and pass it, the remainder of the list. Yeah, this is the test value. Remainder of the list and pass it in here. So we're starting at the end, okay? As long as there are some. I hate this. I really hate new GitHub, man. As long as there are some that we're still going over. if the remainder of the value and the first, which is the last number, is 0, then we keep going with the quotient of this number, of the value in that number, with the same, but we don't, oh, we do, and we move on to the next number. If the value is greater than this number, then we move on to the next number by, oh, oh. Hang on, let me turn the music back on. Okay. Oh. Wait. All right. Why? It's because of this, right? And that you're doing these checks. You're able to do these checks if you start at the end. And you can't do them start at the beginning, right? Like if the last number is just greater than the whole thing, you could just stop, right? You don't have to start at the beginning and check all up to that number, right? I guess the inverse could be true. The big number could be first, just as likely, though, right? Right. But I mean, basically, you're dividing. You're dividing and subtracting and working from the end. Okay, what is this cutoff thing then? Right, so to do it, the square way, as squares would do it, you gotta string concatenate A and B and then make a new number, right? But what you're doing is it even possible to get here by concatenating, right? Is B inside of A somewhere? And if so, we need to deduct that out. Ah, so yeah, it's a reversal operation. Dude, this is so clever. Erdos gets a high five from the channel. This is so clever. Wait, I still don't fully understand. Do you understand, Clojure guy, why this is so much thinking faster? I mean, I can see why it works, right? You start at the end and you invert all the operations and stop whenever you can no longer invert and get to this, right? Why can you not just do that forward? Yeah, clearly. Erdos does rock. I agree. I don't know why I can't do this. I would have to... This is the problem. I would have to sit down and try and write it forward in order to figure out why I can't do it forward. I believe that you can't do it. I just don't see it, you know? Forward, you only know if you are too big. Right? But that's enough, right? Like you could just stop if you're bigger than value, right? If somehow you do an operation and you're bigger than value, you could just stop. I think it might be this. Because you could stop faster. Like, you can't know if TV is evenly divisible. I think this is it. There are too many branches before it might stop. Right. I think this cuts down the number of branches significantly, is my guess. Because this is a pretty... You could do this either way. Right? But this... You could see immediately... Right. Okay. All right. That is it. Yeah, you can see it pretty quickly. Hey, you know, multiplication is not going to work here. And for some reason, adding doesn't work. And you could do these two other checks, but this one, you have to go backwards to do this. Because then if you go forward, you have to do this check. And that's all you got. Right. Nice. Man, what... This deserves like a medal. Airdos, did you... Well, you're not in the chat. I wonder if Airdos came up with this on his own, if he saw it somewhere else. That is so slick. All right, Airdos goes on the wall of fame. I need to make like a wall of fame solutions. Let me write that down. I might do that actually. I'm gonna just put it on the Twitter. I mean, on the Twitch page or something. Alex, this is my life, man. I only know one way. Oh, nice, Misha. That's exactly it. Can't hide. Is anyone? Okay, Zach was in the same boat as me. It just went even faster. The madman. How to get out of string operations? Oh, by doing you know, the mathy version of it. Ah, this guy. All right, Shady. Oh, he did the slow. He did our dumb way. Yep. Have an equation like this. Here comes the optimization. We only have easily invertible operations with times divide and concat. Right. Man, how slick is that? I feel like after seeing that solution, I need like a cigarette. That thing is amazing. Oh, every year I relearn reversing the input is much faster. That's true though. B. Howman. Holy smokes. Oh, that's just part one. Yeah, this is basically the same. Uh-huh. I'm glad I'm not the only one. I mean, like, every third person is like, how does this math trick work? Like, this is incredible. All right. That's it for day 7. I'm just gonna, I thought about, we solved this in like 30 minutes. It wasn't bad actually, but these only get longer. I think the only day I'm gonna do 2 of is 1 and 2, and from here on out we'll just be 2 days behind until I decided to give up. So, yeah. Day 8 tomorrow. Everybody, thanks for stopping by. It's been fun. I need to make a wall of fame for AirDOS. All right. Have a good day. See y'all.